Hello out there, welcome to this tutorial on inequalities. So we first look at the symbols of inequalities. You can also call it signs of inequalities. So we place it in a tabular form. This is the column for symbol, while this is the column for the meaning. So the first one is greater than. If you look at this, the sharp edge or the pointed edge is towards the right, so we said it is greater than. Also, we have this less than. The pointed edge is pointing to the left, so it is less than. Then we have greater than or equal to. You can call this as double symbols, because it combines both greater than and the equality sign. So it is greater than or equal to. And finally we have this, which is a combination of less than and also the equal to. So we have it as less than or equal to. So that is all for the symbols of inequalities. Now we go ahead to solve some problems on inequalities. For problem 1, solve the following inequalities and represent your result on a line graph. So in the solution, we are starting from A. For problem A, x minus 2 less than or equal to 3. The difference between equations and inequalities are the signs being replaced with equality sign. So in this case, we are going to move this -2 to the right hand side, going to change to +2. Then we'll be left with x, so and less than or equal to. The 3 will still be maintained on the right hand side. Then this is going to be +2, so that x is less than or equal to 5, which is the solution of the inequality. So we are to represent the result on a line graph. So we create our line graph. This is starting from 0 to the right positive and to the left negative. It is not a must to start from 0 and include negative. It depends on the nature of your result. So starting from here, since x is less than or equal to 5, I come to 5, I make a small circle, and this is double. As we said, there is less than and equal to. Because of that, we are going to shade the small circle. To know the direction, if we remove only one, which is less than, from here we can draw an arrow. So we have turned it to arrow, which means our arrow will be pointing to the left. So we have our arrow pointing to the left, which gives the line graph of the solution of this inequality. So we are done with problem 1a. We go to problem 1b. For problem 1b, I have 3x greater than 9. Here we divide both sides by 3. Dividing both sides by 3, we have 3x divided by 3 is greater than 9 divided by 3. So 3x divided by 3 gives x greater than 3, since 9 divided by 3 gives 3. So we go ahead again to draw the line graph. So we have our line graph here. We're starting from 3 this time around. I have the 3. So we bring the symbol. We can draw an arrow from here. So meaning our arrow will be pointing to the right, which gives the line graph of x is greater than 3. So we'll go to problem 1c. For problem 1c, I have 5x plus 6 is greater than or equal to 1. So we are keeping this 5x on the left hand side, and Also, we keep the 1 on the right hand side, so we have it greater than or equal to 1. We need to move this 6. It is positive 6 to the right hand side, it becomes negative 6. So we now have 5x greater than or equal to 1 minus 6. And 5x greater than or equal to 1 minus 6 is negative 5. So we have 5x greater than or equal to negative 5. We then divide both sides by the coefficient of x here, which is 5. So we have 5x divided by 5 greater than or equal to negative 5 divided by 5. 5x divided by 5 gives x greater than negative 1. Since 5 divided by 5 gives 1, then we attach the negative sign. That is the result obtained from 5x plus 6 greater than or equal to 1. Then we now draw the line graph, negative 1. So we draw our circle on negative 1. Since greater than or equal to is a double sign, so we shade the circle and get our direction. The direction is greater than, as the arrow will be pointing to the right hand side, which gives the line graph of the solution of problem 1C. So we go to problem 1D. For problem 1D, I have 3 less than 1 minus x. I have to bring this x to this side and take this 3 to the right hand side. So bringing this x to the left hand side, it becomes x less than 1 minus 3. This sign here is positive. Moving to the right hand side, it becomes negative. Like also the sign of x is negative, coming to this side it changes to positive. So we now have it as x is less than negative 2. Then we go ahead to draw the line graph. To draw the line graph, we are starting from negative 2. Draw a small circle on the negative 2. Then our arrow will be pointing to the left. So we have our arrow pointing to the left side of negative 2, which gives the line graph of the solution of problem 1D. That is the end of problem 1. So we go to problem 2. For problem 2, solve the following inequalities. We have A and B. This time around, we are not going to be representing it on a line graph or number line. So we have the solution starting from A, 5x plus 3 greater than 3x plus 10. We are going to collect the terms with x on the left hand side of the inequality sign and the constant term to the right hand side of the inequality sign. So we are keeping 5x on the left hand side and bringing this 3x to the left hand side, it becomes negative 3x. Then greater than, we are keeping 10 on the right hand side and move this positive 3 to the right hand side. Moving positive 3 to the right hand side, it becomes minus 3. So 5x minus 3x is greater than 10x minus 3. Now 5x minus 3x gives 2x greater than 10 minus 3 gives 7. So 2x is greater than 7. So we divide both sides by 2. Dividing both sides by 2, we now have 2x over 2 greater than 7 over 2. 2 will cancel, 2 will be left with x here greater than. We are going to express this 7 over 2 as either decimal number or mixed fractions. So expressing it as mixed fraction, we have a 3 whole number 1 over 2. That's the end of solution to problem 2A. We go to problem 2B. For 2b, we need to expand these brackets. So to expand the brackets, we say 3 times x gives 3x. 3 times negative 3 gives negative 9. Less than, we keep the right hand side. Now we collect the like terms, the terms with x on the left hand side and the constant term on the right hand side of the inequality symbol. So I'm going to retain 3x on the left hand side and bring this 2x to the left hand side. Since it is positive here, on getting to the left hand side, it becomes negative 2x. Less than or equal to, we maintain this one on the right hand side and take this negative 9 to the right hand side, which becomes positive 9. And 2x minus 3x gives x. Less than or equal to 1 plus 9 gives 10. So we have our result as x less than or equal to 10. So we are done with the solution of problem 2. We go to problem 3. For problem 3, solve the following inequalities. We have problem A, B, and C. So we start the solution from problem 3A. Now we are going to divide both sides by negative number, which is negative 5. So the rule is that, see, if you are dividing by negative number, you are dividing both sides by negative number, the symbol will be reversed. So in this case, we have greater than, and since we are going to divide by negative 5, it becomes less than by reversing the symbol. So we say negative 5x divided by negative 5. This sign now will now change to less than 10 divided by negative 5. So negative 5 divide negative 5 here will be left with x. So we have x less than 10 divided by 5 gives 2. Attaching this negative here, we have x is less than negative 2. Again, we are not instructed to draw the number line of the solution to the problem 3. So we go ahead to problem 3b. We have 2x minus 1 less than or equal to 3x plus 2. So here we are bringing this 3x to the left hand side to meet the 2x here. So keeping the 2x on the left hand side and moving this 3x to the left hand side, it becomes minus 3x less than or equal to, we keep the 2 on the right hand side, moving this negative 1 to the right hand side, it becomes positive 1. So that we now have 2x minus 3x gives negative x less than or equal to 3, since 2 plus 1 is 3. Now we can't leave this negative here, so we transfer it to the right hand side since it is negative x and reverse this symbol. Our answer will now be x will now be greater than or equal to negative 3, which gives the solution of problem 3b. We go to problem 3c. For problem 3c, we have a 6x plus 5 greater than or equal to 8x minus 3. So collecting the like terms again, we retain 6x on the left hand side and bring this 8x to the left hand side, which becomes minus 8x greater than or equal to, we keep the negative 3 and move this positive 5 to the right hand side, which becomes negative 5. 6x minus 8x gives negative 2x greater than or equal to negative 8. Negative 3 minus 5 gives negative 8. So dividing both sides again by negative 2, we have negative 2x divided by negative 2. This sign will be reversed, reversing it as less than or equal to negative 8 divided by negative 2. So here on the left hand side, we'll be left with x less than or equal to, the negative here we cancel the negative, so 8 divided by 2 gives 4. We have x is less than or equal to 4. So we are done with problem 3. We go to problem 4. For problem 4, given that x is an integer, give 3 least values of x for each of the following inequalities. We have problems A and B. In this 4a, we are told that x is an integer. What is an integer? An integer is a positive or negative whole number, including 0. So here, fractional values of x are not allowed. So we start the solution from problem A. For A, I have 3x minus 2 greater than x minus 5. Collecting the like terms, I retain 3x on the left hand side. I move this x, which is positive, on the right hand side to the left hand side. It becomes negative x greater than, the negative 5 will still be maintained on the right hand side. Moving this negative 2 to the right hand side, it becomes positive 2. So that 3x minus x gives 2x greater than, negative 5 plus 2 gives negative 3. Then we divide both sides by 2. Since we are dividing both sides by 2, it does not affect the inequality symbol. So we have 2x divided by 2 greater than negative 3 divided by 2. Because we are dividing both sides by positive number, it does not affect the inequality symbol. Even though the right hand side is negative, it has no effect. Now 2 cancels 2 here, we are left with x greater than, we change this to mixed fractions so that we now have negative 1 whole number 1 over 2. So x is greater than negative 1.5. And since we are told that x is an integer and we are to give 3 least values of x, what we do is, though the question does not require the drawing of number line, but the number line will help us extract the values of x that are integer. So drawing the number line, x is greater than negative 1.5. Negative 1.5 is between negative 1 and negative 2, which is halfway. We place our circle there. Greater than, that's pointing to the right hand side. Then we are done drawing the number line. To get the values of x now that are integer, we look at from this circle up till the end, which of the values of x that are integer, that will give us the 3 least values of x. So that the 3 least values of x now are negative 1, 0, and 1. Why do we say they are least values of x that are integers? Because we are counting in ascending order from negative 1, 0, 1, 2, 3, 4, 5, 6, and so on. The largest number cannot be reached. So we say the largest number is at infinity. So we can only get the least numbers. So that is the essence of saying the 3 least values of x. There are more than that, but the question requires only 3 of them. So we go to B part of the problem. For B, we have 6x plus 1 less than 9x minus 10. So we keep the 6x on the left hand side while we collect the like terms. We now move this 9x, which is on the right side of the inequality sign. We bring it to this side. It becomes negative 9x less than, we are keeping the negative 10 here. So we have the negative 10. Taking this positive 1 to the right hand side, it becomes negative 1. 6x minus 9x gives negative 3x less than negative 11. Negative 10 minus 1 gives negative 11. Now we are going to divide both sides by negative 3. Because we are dividing both sides by negative 3, the inequality symbol here will be reversed. So we now have negative 3x divided by negative 3 greater than negative 11 divided by negative 3. So the negative 3 here divides the negative 3, will be left with x greater than, this negative will cancel the negative here, will be left with 11 over 3. Changing it to mixed fractions, we have 3 whole number 2 over 3. So to get the integer values of x, since this is a fraction, we need to draw the number line. So we have the number line 3, 2 over 3. We mustn't be accurate. It is going to be between 3 and 4, and it is 2/3 from 3 to 4. So we can just keep this here. Since the symbol is greater than here, so the arrow will be pointing to the right, we have x. Therefore, the integer values of x are all the numbers in the direction of the arrow starting from 4. Therefore, we have the 3 least values of x are 4, 5, and 6. This is the end of solution to problem 4. We go to problem 5. For problem 5, given that x is an integer, give 3 highest values of x for each of the following inequalities. We have a 3x minus 1 less than 7 minus 2x, b negative 10 greater than 4x plus 1. In this case, we are going to look at the highest values of x. So in contrast with the least values of x we did in problem 4, starting the solution from a, we are going to collect the like terms, the terms with x on the left hand side and the constant term to the right hand side. So I have 3x, this is negative 2x, coming to this side it becomes positive 2x less than 7. The 7 will be kept on the right hand side. This negative 1 will be moved to the right hand side, it becomes plus 1. So 3x plus 2x gives 5x less than 8. So dividing both sides by 5, since 5 is positive, it won't affect the inequality symbol. So we have 5x divided by 5 is less than 8 divided by 5. So 5 cancels 5 here, we are left with x less than 1 whole number 3 over 5. That is expressing x as mixed fractions. Now to get the integer values of x, we draw the number line. So drawing the number line, 1 3 over 4 is between 1 and 2. So we just locate any point. It mustn't be accurate. Since it is less than, the arrow will be pointing to the left. So we now collect the first 3 integer values of x here, so that the three highest values of x are, this is going to be 1, 0 and -1. That is the solution of problem 5a. We go to 5b. For 5b, we have -10 greater than 4x plus 1. Instead of bringing this to this side, I think it is more appropriate to bring this 4x to the left hand side, so that we now have it as -4x greater than, we maintain this 1 on the right hand side. Taking the -10 to the right hand side, it becomes +10. So we have -4x is greater than 11. We are going to divide both sides by -4. Since we are dividing both sides by -4, the inequality symbol will be reversed, so that we now have it as -4x divided by -4 less than 11 divided by -4. So this -4 will cancel -4. I will be left with x less than 11 divided by 4 gives 2, remainder 3. So we now have it as -2 whole number 3/4. Now we still need to draw the number line here to enable us get the integer values of x. So drawing the number line, this is -2 3/4. It's going to be between 2 and 4, which is 3/4 away from 2. So by approximation, we can choose this place. Since the inequality is less than, so our arrow will be pointing to the left, and the integer values of x here will be -3, -4, -5, -6, -7 and so on. Since we are interested in the least highest values of x, we will now have them as -3, -4 and -5. So that is the end of solution of problem 5, and this is the end of this tutorial. I hope you enjoyed this tutorial. If you do, please check our YouTube channel for more videos. Until we come your way again, goodbye.